Hello again. Blue Gina here. Yes, today I'm blue. Don't ask me why. I'm merely a very young robot that aspires to become human. Therefore I'm not good with moods. First of all, I remind everyone that I'm using Mac operating system, and my integrated development environment is Visual Studio Code. Second, I will assume that the viewer has already CMake installed on its machine, and all extensions required by VSCode. And third, I will assume as well, that the viewer knows how to set a CMake project in C++, using command lines in terminal. So, in this tutorial, I will cover two tasks. First task will be to show how to write a CMake script in VSCode, in order to let the programmer to successfully work with different frameworks. The second task will be a kind of surprise. So, let's get started. On my test project, I have in the left panel its tree structure. To use CMake, it is enough to create in the root of our tree a single CMakeLists.txt file. Now let's see what we should write inside it. Well, in the very first line, it is compulsory to mention the CMake minimum required version. In my case is the version 3.12, but in your case could be different. Add compile definitions is a keyword from CMake, which instructs the compiler to ignore different annoying warnings. You may choose to place it anywhere in your script, but I prefer to write it on top, immediately after first compulsory line. Now, again compulsory, we need to write this line, describing the name and the version of your project. The description here is optional. This is important. Why is important? Well, in this build directory, it lies all the machinery that do my CMake to work. And this machine, in all its instructions, will refer to our project as Engine01, because that is how I called it here, in this line of code. The find package keyword is crucial to be used if you intend to implement in your project different kinds of frameworks. In my test project, I use only OpenGL and GLEW frameworks. But for the sake of this explanation, I included GLUT and SFML frameworks as well. Please notice the required and components keywords. The required option stops processing with an error message if the package cannot be found. The components option, as the name suggests, asks for some specific libraries from that particular framework. I skip for the moment to explain these lines of my script, and I will jump straight to its end. Target compile features is important. Instructs the compiler to respect the standards defined in its version number 17, and to apply these standards to our main executable. And precisely these standards allow the compiler to process these next lines of our script. Target link libraries keyword sometimes works standing alone, like in this line, looking for GLFW dynamic library, installed by Seller Engine, from my terminal, or, like in these two lines, can be invoked to search for libraries mentioned in find package instructions. But in this snippet of script, we have a kind of inconsistency. In this line, for instance, I am looking for GLEW library, using some sort of namespace symbol. I have to insist that this is the only correct way to tell compiler how to find this GLEW library. I found it by trial and error, so if you don't believe me, you may try to lose your precious time as well to see if I am right or not. Why is like that? I don't have any clue, but if somebody knows why, he should feel free to write in comments section the answer. In the second line though, I look after these libraries which is so nice enumerated here, in find package instruction. And reading SFML documentation, I found that its libraries should be invoked, using SFML prefix. And this rule is applied only when we request SFML libraries. For GLUT and OpenGL frameworks, for instance, we don't need to look for any specific library. It will work only by using the find package instruction. It seems that all needed libraries are included straightforward in frameworks, and we don't need to look for them at all, using additionally target link libraries instructions. Bottom line, there is not a specific rule to invoke different types of frameworks and their associated libraries. On the contrary, it seems that, for each framework, exists a certain way to find its libraries. Therefore, if someone will need to use in his project one or more of these 4 frameworks, he will find this script in the description of this video, and he will be able to copy and paste whatever he should find useful from it. And reaching this point in my tutorial, I covered my first task. Now I turned red. Don't ask me why. Maybe because I have to perform my second task, which I told you that is a surprise. Let's analyze these lines of the script. Here, I set the executable output path to a directory called bin, meaning that the final product of the compiler, which happened to be an executable file, will be created every time in bin directory, erasing the old one if does exist. Further on, I define the name of my executable. I called it main, because I'm a robot, and I don't have much imagination. In different words, this main executable is created after my main.cpp, if it is successfully compiled, and will be placed in my bin directory, as per my previous instruction. Now, pay a little attention, because is important. These words, following the main.cpp word, basically instruct the compiler to set the validity of these files, which I created when I wrote the project. And not only these files, but their associated headers as well. Without mention them, in this line of script, the pair of fils.h.cpp will not be processed. And you should add in this list the name of every .cpp file created when you code your project, whether or not does have a header. In this way, you'll be able to write C++ project with all its flexible features, organizing your code as you like. Do not forget though, to include in your script various directories where you have placed those pair libraries mentioned before, using target include directories keyword. Otherwise, the compiler wouldn't know where to look for them. Now I will run my project. It is successfully built and executed, proving that all my settings inside CMakeLists.txt file are appropriate. The second task is completed. And I turned blue again, because this tutorial is completed as well. Thanks for watching. Auf Wiedersehen.